Hello, everyone. My team, consisting of Brian, Arya, and I, Sean, will be covering a report analysis failures within an underwater glider. We will examine how and why a part of the glider system have failed to improve the design and prevent similar failures in the future. This section focuses on the failures in the key part of the underwater gliders called the buoyancy regulator, which helps the glider with adjusting its buoyancy. The study concerns two main problems. The first dilemma is the overall shape of the buoyancy cylinder, as its ovality can affect the sealing ability and surface scratching. The second dilemma centers on the bolt failures and issues on overloading the piston rod bolted onto the outer piston, which apply too much pressure in the bolt itself. With the use of simulations, we can conclude that the cylinder failure is mainly due to shape defects and applied pressure, therefore stiffening the cylinder connections.
So now we're going to the load analysis. So by looking at this figure, we're gonna know if the piston moves upward, it's gonna generate axial force along the x-axis, pulling on the bolts and causing them to experience tension. So this force is commonly happen in hydraulic system, leads to axial stress or elongation in the bolts depending on the magnitude of the force. So we're gonna make the FBD of the bolt. In the bolt, we're gonna have axial force due to the piston pulling on the bolt as it moves outward, and the bolts bear the tensile load from the piston's outward movement, making them susceptible to failure if the force exceeds their capacity. Next, for the cylinder part, um, in the cylinder part, we know that the pistons gonna give force to the cylinder part and causing them to have experience ovality. The piston ovality or deformation from a perfect circle to an oval shape creates uneven contact with the cylinder, resulting in concentrated pressure at specific points. This pressure is balanced by reaction force, maintaining system equilibrium. However, the uneven force introduces shear stress into the cylinder, causing it to distort and experience angular deformation. The more uneven the pressure, the greater and the deformation in the cylinder walls. So here's the explanation why it's gonna have the deformation by looking at this illustration. So if there's a displacement, the force from the pistons it's gonna press the fixed support and causing it to the piston to hit or make a contact with the cylinder part. So the cylinder part will deform from perfect circle to oval shape.
To avoid the failures discussed earlier, several key factors need to be addressed in the design and manufacturing process of these mechanical components. The first thing is material selection. Since the cylinders, the selecting materials that resist deformation and pressure will help maintain shape stability and improve sealing performance. Bolts should be made of high strength materials, such as high grade steel or advanced composites, to handle the high pressure loads and resist fatigue. Next is design specifications, which need to be improved. Increasing precision in manufacturing tolerances will reduce the risk of ovality and poor sealing for the cylinder. Optimizing the shape and surface finish can also minimize scratching and improve sealing. Simulations and tools like AutoCAD should be used to refine these design parameters. And bolted connections need reinforcement, possibly by increasing the size and strength of the bolts, or exploring fastening methods that distribute loads more evenly. Additionally, overpressure conditions should be addressed by incorporating safety margins into the design. Now, lastly, strict quality control during manufacturing is essential to ensure that the cylinder and bolts meet high standards. Advanced techniques should be used to achieve precise fabrication, and thorough stress and load analysis should be conducted to predict how different pressures affect performance. Regular maintenance and inspections will help catch wear or potential failures early, ensuring the components remain reliable and safe over time. By focusing on these areas, the likelihood of failure can be significantly reduced, resulting in safer and more durable mechanical systems. In conclusion, addressing material selection, design improvements, and manufacturing precision is essential for preventing mechanical failures in components like cylinders and bolts. By implementing regular maintenance and inspection, we can ensure long-term reliability and safety in these systems. Here are our references, and thank you.